Yeah, so hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a couple of popular Q&A. These questions are related to mathematics at high school and university level. And a little bit background about myself. I am an undergraduate student. I'm studying Bachelor's of Technology in Aerospace Engineering. And if you need any tutoring help or if you need any homework help, then you can check the links in the description below. So let us start. I just need to start. Okay, so yeah. Okay, let me just check. Yeah, it is switched now. So our first question is yep. So what are different log properties? So logarithmic properties. Yes. So let us see what the answer is given. Okay. So first I will start with first property. So suppose if I have this is the log of say base a and the number is x which is equals to y, let's say, then when I take the anti-log, so when I take the anti-log, then it will become a power y equals to a log of a into x. So suppose if I'm taking anti-log with a, then everything will go into the power of a. Now, suppose I have a log. Mm, let me use blue color. So suppose I have a e and x. So if the power which we have raised to and the base of the log is equal, then we can this log kind of vanishes and we have only x here. So e log base e x equals to x. So if the number at which we are raising the log is the same as the base of the log, then the log vanishes and we have only x. So in this case also, my a power y will be equal to my this number and the base of log is equal, so a power y equals to x. This is the property of log. Now, so yep, this is the property of logs where a is the base, y is the exponent and x is the number or the argument of the log. Okay, then we have product rule, quotient rule and power property. Okay. Wait a minute, I just need to transform this page to A4 size onto A4. Yep. So now we'll go for product property. Product property. Okay, so log of base a x into y will be equal to log of base a into x basically log of x with base a plus log of y with base a. So whenever we have a log of two functions are multiplied with each other, then we can separate those functions with this product property of log. So it will become log of first function plus log of the other function. So here in this case, I had one function or I had one value x and I had one variable y. Then I can separate these two by using log of by using this product property, and I can write log of log of x with base a plus log of y with base a. Uh, C property, third one, is the quotient property. So y will be equal to it will be log of base a into x minus log of base a into y. We can also prove this property, or we can also just derive this property using the product rule. So I can also write this as log of a x into y inverse. So if I write like this, okay, just we'll come to this after the other property. So whenever we have two numbers inside the log, or whenever we have two numbers and log is operated on those two numbers, and those two numbers are divided with each other, then we can just use the this quotient property, and we can write log of x with base a, or log of the numerator. So this is my numerator, this is my numerator, and this is my denominator. So log of numerator with base a minus log of denominator with base a. Then we have another property t, which is power property. So in the power property, if I have, suppose, say log, this time I'll use the natural log with base e. If I have log a, and if I have a number x and a number is on the exponent, or a number is, or it is raised to power y, then I can bring this y here by using the power property of log. So it will become y times log of base e and x. This log, I'll just write ln for simplicity. Okay, and this is pretty much given. Okay, let me just cross check. There is one more property of log. Yep, so there is one more property, and this is suppose if we want to change the base of a log, it is called change base. So suppose we have a log, say log have say e, or let's just say any random number x, say x a over log of this b with same base. So like if I have a number, say suppose say log of 10 with base 10, then I can write if I want this in the natural log, so I can write log 10 over log of base e of 10, and this will just cancel and I will get 1. So this was a unique case where I was getting 1. I can also write like log of base 9 and 10 as log of natural log of 10, or the numerator, and log of natural log of 9. Okay, that was pretty much. So the solution is power property solution is correct. I'll just add one more. Mm, Solution is correct. Great job. There is one more property of changing the base of log, where log of a is equal to log x of a divided by log base x of b. So yeah, that was pretty much for log. The solution is correct. We'll go to the next page. This is going to be the question number 2. What is the equation of a sphere in standard form? So equation for circle was, let's say this was center and its coordinates are h comma k, then x whole square plus y minus k whole square equals to r square, where r was the radius of the circle. Now here I cannot draw the 3D structure, but if we add one more dimension in the z component, so I can, how I don't know how can I draw a sphere. So suppose if I take and let's say this is the z direction. So if I add one more dimension and if I have a center point here, then the coordinates of center point will be h comma k for x, for y, and for z I will have one more which will be k. Now my equation for sphere will become h minus x minus h whole square plus y minus k whole square plus another component z minus l whole square equals to, gain the square of radius, to r square. H minus x minus h whole square plus y minus k whole square plus z minus l whole square. Yeah, so the solution given here is correct. Correct solution. Great job. Solution is correct. Now I will go to the third question. Question number 3. What are the roots of unity? Okay, so roots of unity are those number when raised to a positive integer will give an answer of 1. Okay, so roots of unity. Yep. So suppose if I have a number, wait, black roots of unity, then I will use red. So suppose I have a number, and if I raise that number to nth power, then n is basically the my nth root. For nth root I'm writing this n. So for first root I will write just 1. For second n will be 2. So my for nth root my z power n should be equal to 1, where n are positive integers 1, 2, 3, 4. If I further elaborate, then my z power n will be basically e power, if I write it in this complex form, e power I times 2 pi into k, which will be equal to cos of 2 pi k plus I times sine of 2 pi k. Now for evaluating only z, I can just take the rest, I can just multiply with um, reciprocal of power, or 1 nth root plus I times sine of 2 pi k raised to the power 1 over n. Then z will be, now there is a theorem called de Moivre's theorem. In that, if I have a complex number and if the complex number is raised to certain power, then this power can be, so this power can be multiplied with the argument of the angle, argument of the trigonometric ratios. So my z will be equal to 2 pi k over n. So I'm multiplying with 1 by n, so it will become n plus I times sine of 2 pi k over n. Yep. Okay. Now with this we can just form a circle, and let us say that omega is equals to cos of 2 pi k over n plus I times sine of wait a minute, fix number, Now if we, okay, this will be for k equal to 1. For k equal to 1, I will have um, c equal to co cosine of 2 pi by n plus I times sine of 2 pi by n. Now let's say that omega is that e power 2 pi by n I times, which is cos of 2 pi by n plus I times sine of 2 pi by n. So if I write, let's say for n equals to 1, my omega will be, this will be cos of 2 pi plus I times sine of 2 pi. So sine of 2 pi will be 0, cos of 2 pi will be 1. So for n equals to 1, or my first root will be 1. For n equals to 1, equal to 1, root of unity is 1. Same way, for n equals to 2, I can write omega will be equal to cosine of 2 pi by 2 plus I times sine of 2 pi by 2. So, okay, that will become omega is um, mm, mm, yep, so cos of pi will be minus of 1 and sine of pi will be 0 again. So it will be minus of 1. So for n equals to 2, root of unity is minus of 1. For n equals to 3, n equals to 3, I have omega as cos of 2 pi by 3 plus I times sine of 2 pi by 3. So for n equal to 3, my root of unity is will be, let me just calculate the value. So cos, I need to change this to radian. So 2 pi by 3 will be basically, if I convert it into degrees, so pi by 3 is 60 degree. 2 pi by 3 will be 120 degree. And okay, so cos of 120 degree of 120 is negative of 1 by 2, negative of 1 by 2, and sine of 120 is plus I times sine of 120 is plus, it must be root 3 by 2, root 3, yup, this will be I times root 3 by 2, or we can also write this as negative of 1 plus I times root 3 over 2. So these are the first three roots of unity. So the solution given was correct. It was just not that much elaborated. Great job. Just do one thing. I think that the n equal to 2 1 was correct. Cos of 180 will be -1, sine of 180 0. Okay, that was correct. So solution is correct. Great job. Add a page. This was question number 3. We will move towards question number 4. So what are right triangle congruence theorems? Okay. So let us see. Um, so we have 4 of them mentioned here. Okay. So first I will start with the hypotenuse acute theorem. So if the hypotenuse and an acute angle of a right angle triangle are congruent to the hypotenuse and an acute angle of another right angle triangle, then the two triangles are congruent. Note this statement is same as angle side. Okay. So for deriving this right triangle congruence theorem, we'll basically use the basic theorems of um, basic congruency theorems of triangle. This is one triangle, let's say. This is another triangle. So first we'll go with the hypotenuse HA1. Let's say this is A, B, C, D, E and F. This angle is 90 degree as stated. Now it for now suppose let's say this is one acute angle at F and angle at B is already equal to angle at E, and let's say the hypotenuse we are using, okay, this side. Let us say AC is equals to DF, then what sides are left? If this side is equal to this side and the angle is same, then this angle must be, suppose if say this is 30 degree, this is 30 degree and then this is 90, and the sum of interior angles of triangle is 180 degree. So 30 plus 90 equals to 180. 30 minus 90, we'll subtract this from 180 and we'll get this angle as 60. 60 and 60. So again the third angle is also equal, and with this with the angle, so angle and side, we can say triangle ABC is congruent to triangle DEF. The second one was leg acute theorem. So in this, if a leg and an acute angle of one right triangle are congruent to corresponding parts of the another right triangle, then the two right triangles are congruent. This is done by angle side angle postulate. Okay, again I'll just draw one triangle, right triangle. Again ABC, DEF. Let's say for this we have this acute angle. Okay, we have this perpendicular, and let's say for side we'll take this side, and for this one we'll take this one. Basically I should be taking this side. So now if it is proven that angle B is equals to angle at E, then if I say my A, not A, my DE is equal to BC, and my angle at C equals to angle at D. So we say these two triangles ABC congruent to triangle DEF. Hence, my AB will be equal to EF, and AC will be equal to DF. Now, and then another one is, okay, the side angle side postulate. Okay, so the third one is leg theorem. So in this, if we have a right angle triangle, then if we have one more right angle triangle, this is 90, this is 90, this one equals to this one, and these are equal. So A, B, C, D, E, F. So AB is equals to EF, and BC equals to DE. Angle at B equal to angle at C. Therefore, with side angle side postulate, I can say my triangle ABC is congruent to triangle DEF. So in right angle triangles, basically we have the liberty, or we have the privilege that one angle is already at 90 degree. We know one angle and it is going to be equal to the other angle. fourth property we have hypotenuse leg theorem. Okay, suppose I have one triangle, hypotenuse leg theorem. I have one more right angle triangle is equal, and this side is equal. So if AB equal to EF, angle at E equal to angle at B, and my AC equals to EF, then again with side angle side theorem or side angle side postulate, I can say these two triangles are congruent. EC is congruent with triangle DEF. Hence my BC will be equal to DE, angle triangle, to prove the congruency between two triangles. The solution is correct. Solution. Great job. That was the question number 4, I think. Yeah. So this will be question number 5. What is the derivative of y equal to tangent of x? So this is very simple. Dy by dx will be equal to secant square of x, because derivative of tangent of x is secant square x. Correct. Solution. Great job. Solution is correct. We'll go to question number 6. Oh. Okay, so question number 6, we have simplified the expression cosine of 2 sine inverse of x. Now we are going to do this question with some substitution. So as I can see, I have 2 sine inverse of x. So what I will do, I will use the property, or I will use one property of trigonometry, double angle property. Cosine of 2 times of theta equals to 1 minus 2 sine square theta. So okay, now let's say in this formula I'll keep theta as sine inverse of x. So my expression will become cosine of 2 times of sine inverse of x which is basically the my question only. So cosine of 2 times of theta, and theta here is sine inverse of x, equals to 1 minus 2 times sine square of sine inverse of x. I can write this as 1 minus 2 times of, just to simplify, because I can write this, I can write say sine square theta as sine theta whole square. This square will operate only on the sine operator, not on the theta. So sine of sine inverse of any angle is equals to that angle only, or sine of sine inverse of any number is basically the number itself. So I will have 1 minus 2 times x of whole square, which will be equal to 1 minus 2 times x square, and this is my answer. So my cosine of 2 times of sine inverse of x will be equal to 1 minus 2 times of x square. 2 times of x square. Okay, solution is correct. Correct solution. Great job. Solution is correct. This was question number 6. Now question number 7. We have find the derivative of, so we need to find dx of hyperbolic tangent of x. Okay, so well, basically hyperbolic trigonometric ratios, when we differentiate with respect or when we differentiate, then there is no special condition, because whatever formulas we have in the case of trigonometry, whatever formulas or rules we have differentiating a trigonometric ratio, the same formulas will be applied in the case of the hyperbolic trigonometric ratios. So in short, I can say that it will be secant square hyperbolic of x, and let's see, secant square hyperbolic, oh sorry, I should write this square hyperbolic x, but I'll just go with this solution to explain you further. So my tangent of hyperbolic of x will be equal to sine hyperbolic of x over cosine hyperbolic of x. Now my sine hyperbolic of x will be, there is one property, e power x minus e power minus x over 2. It was 2, or I think 2. It was 2i. I'll just confirm this. Yep, so it was 2 only. And then for cosine hyperbolic of x, we have e power x plus e power minus x over 2. Then we will just write tangent of I do not have the practice of writing hyperbolic trigonometric ratios equals to e power x minus e power minus x over 2 over e power x plus e power minus x over 2. Now let us see what they have done. Okay, now we'll just differentiate this. So we take the derivative with respect to x, tangent hyperbolic of x equals to, now yeah, we will just cut this. Now we are going to use the quotient rule of the differentiation. So it was like d uh, it was like d dx of u by v, where u and v are functions of x. Then um, it will be v times d dx of u minus u times d dx of v over v square. So I will write d dx of tangent hyperbolic x equals to, first I will keep the denominator and differentiate the numerator. So e power x plus e power minus x times differentiation of e power x minus e power minus x minus, now I will keep the first or the numerator constant, minus x minus e power minus x with, and I will take the derivative of the denominator, e power minus x over e power x plus e power minus x square of denominator. Now I will write e power x plus e power minus x. Derivative of e power x will be e power x, and derivative of e power minus x will be minus of e power minus x. This minus minus will become plus, now minus e power x minus e power minus x times derivative of e power x is this, and e power minus x will be e power minus x. So over e power x plus e power minus x whole square. Now what I should do, I have the square of these two terms, so I will just square them. So I will just multiply these two. It will become e power x plus e power minus x whole square minus e power x minus e power minus x square over e power x plus power minus x whole square. Now if I open this square, then I will get e power 2x plus e power minus 2x plus e power plus 2 times e power x, e power minus x will be 1, and repeat, minus e power 2x plus e power minus 2x, then minus of 2 times e power x, e power minus x, so that will be 1 over e power x plus e power minus x. Now the here they have taken, okay, so here I am doing a mistake, so I can just separate. Okay, so we do not need to do this. We'll just separate this, e power x plus e power minus x whole square over e power x plus e power minus x. This was the simplest approach. I was unnecessarily opening this square. E power minus x, this and this will get cancelled, so I will have 1 minus e power x minus e power minus x over plus e power minus x, and I'll just take the whole square outside, and this was equal to tangent hyperbolic of x. So e power x minus e power minus x, we have the same term here, e power x minus e power minus x, and on the denominator we have plus sign, so this will be 1 minus tangent hyperbolic square of x, which will be secant hyperbolic square of x. So derivative of tangent hyperbolic of x equals to secant hyperbolic of x. In short, the answer which I told earlier. Again, correct solution and create job. Just submit the solution. This was question number 7. We'll go to question number 8. Question number we need to find derivative of secant of x. So for this we just have the direct formula. Derivative of secant of x is nothing but secant of x into tangent of x. If we want to derive this, then secant of x is basically 1 over cosine of x. We use the quotient rule for this. So 1 times cosine of x times derivative of 1 will be 0, and then minus 1 times cosine, derivative of cosine is minus sine, square x. So this will be sine x over cosine x times 1 over cosine x. This will become tangent of x, and this will again become secant of x. T dx of secant of x. Okay, the proof is also given in the same way here, which I did. So final answer is secant x and tangent x. Okay, correct answer. Correct answer. Great job. So whenever we have a complex like tangent, derivative of tangent of x, or derivative of say secant or cotangent or cosecant, then we can just convert it into sine and cosine, and then we can do the differentiation. So this will be my question number 9. We need to verify sine of t times cosecant of t equals to 1. This is a very simple question. We'll just use the relation cosecant of t is basically 1 over sine of t. Then we'll substitute back into the equation. This and this will get cancelled and it will be equal to 1. LHS equals to RHS, hence proved. Okay. Correct solution. Great job. This solution is correct. I will go to so the question says that how to transform the general form of hyperbola to the standard form given by the equation. So equation is 3x square minus 2y square minus 24x minus 12y plus 60 equals to 0. So for this case, first I will write the general, the standard equation of hyperbola. So the standard equation of hyperbola is it is x minus h whole square over a minus y minus k. So y minus k whole square over b equal to 1. Now x minus h whole square minus y minus b whole square. Here h and k are the center coordinates of the hyperbola. Center of hyperbola. Then we have we have this the length of transverse axis. So 2a is length of transverse axis, then we have the distance between the foci is 2c. 2c is distance between foci of two hyperbolas, which is given by c square equals to a square plus b square. Then we have coordinates of the vertices. So the coordinates of the vertices are h plus minus a comma k. Then we have coordinates of co-vertices, which is h comma k plus minus b. So we need not to dive into this. We just need to convert this black equation into this blue equation. So let me just rewrite this equation. So it was 3x square minus 2y square minus 24x minus 12y plus 60 equals to 0. So first I need what do I need? I will just divide this whole. Nope, I will just take separate the x terms and y terms first, because I need to complete the square for this conversion. 2y square minus 12y plus 60 equals to 0. Then I will take 3 common from here. So x square minus this was 3 8 times x. I will take minus 2 common from here. Then this will be y square minus 6y, that will be plus, and I will take 60 on the RHS side. Now I will complete the square within the bracket. So I have 3, I have x square, then I will write 2 by 2 into 8. So I can write 8 as 2 into 4. I can write 8 as 2 times 4 times x. Then for the b square term, I'll just write these formulas. A plus b whole square equals to a square plus b square minus 2ab, and a minus b whole square equals to a square plus b square minus 2ab. So for this was minus, this is 2, this x is a, then b will be 4. So I will add 1 4 square and I will subtract 1 4 square minus 2 times y square plus 6 can be written as 2 into 3 into y, plus this is 2 times, here this will be plus. So this is 2 times a into b, so I will add 3 square and I will subtract 3 square. Three square equals to negative of 60. Then I will complete the, or I will write in the form of square. I will just combine these terms. So I will get 3 over, for this I have x square. This will be x minus of 4 whole square minus 2 times y plus 3 whole square equals to negative of 60. Now for the general form, we need 1 on this side. So what we will do, we'll just divide everything by okay, so I left few terms here. Here I had 4 square also. I will just erase. Red pen. So I have 3 times x minus 4 whole square minus 4 square minus 2 times y plus 3 whole square minus 3 square equals to negative of 60. Now I will just 3 times x minus 4 whole square minus 3 times 16. 3 times 16 will be 48. Negative of 48 minus 2 times of y plus 3 whole square minus 3 square. So this minus will become plus and this will be plus 18. 48 now equal to negative of 60. So negative of 48 and 18 will become minus 48 plus 18 will become minus of 30. So I will take wait a minute, 3 times 48, then I had this was minus and negative 2. Okay, minus minus becomes plus and 2 times of 9 is 18. This will be minus 60 and then factor using here it is given 3x square 8x minus 2. This minus minus will become plus, then 2 into 9 will be 18. So plus 19 plus 19 it will become minus of 18. So this will become 3x minus 4 whole square minus 2 times y plus 3 whole square minus of 30 equals to minus of 60. I'll just add 30 on both these sides. Then we get 3 times x minus 4 square minus 2 times y plus 3 whole square equals to, this will be 0 and this will be minus of 30. Now I will divide both the sides with negative of 30. was 3x minus 4 whole square minus 2 minus 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 48 plus 18 negative 30. Negative 30 will go become positive 30. So I will divide this whole with negative of 30. Then I will get this will become in the denominator. So will become minus 30 x minus 4 whole square over negative 30 over 3 minus y plus 3 square over negative of 30 over 2 and negative 30 over 2 equals to 1. So the general form was x minus c. We need a, we need a minus sign here, and this was red color. So we will get x minus 4 whole square over negative of 10 minus y plus 3 whole square over negative of 15 equals to 1. So this is the answer which I am getting. Here there is a mistake. This should be a positive number in the LHS, and when it goes to the RHS it will become a negative. So this should be minus of 18, then minus 60 plus 48 minus 18 will give minus of 30, and then we'll divide. So the solution given here is incorrect solution, and this one is the correct solution. While completing the square for y terms minus 2 into minus 9 will become plus 18 on RHS and it will become minus 18 on LHS. So on LHS we will have minus 60 plus 48 minus of 30, which will give minus of 18. It was minus of 18 will give minus 30 on RHS. On LHS this will be RHS, this will be RHS, and this will be RHS. Then we divide whole equation with negative of 30. Final answer is x minus of 4 whole square minus, not minus, divide by minus of 10 minus y plus 3 whole square divide by negative of 15 which will be equal to, where is equal to 1. Solution is incorrect. Yeah, so that was pretty much for this session, and if you like this session then please do hit the like button and subscribe button also, and you can leave the comments. And if you want to submit your own questions, or if you want any homework help, then you can check the links in the description below, and hope to see you soon in the next video. So bye.